Hi there, Girl Scout seniors. Mrs. Lori here, your virtual program coordinator. And today we're working on earning step 4 of our Science Space Expert Badge. So far, we've learned a lot about outer space and the universe around us to become an expert in the science itself. But step 4, we're going to do a really awesome science experiment today to learn a little bit more about light in the darkness of the universe. Did you know that we learn more about the universe by collecting and analyzing light? So, do you know how far away the moon is? Or do you know how far away certain planets are? Scientists, or specifically astronomers, study this every day by collecting and analyzing the light around us. They use something that's called a standard candle. A standard candle is basically a consistent brightness of light, kind of like a starting point. So think of a street light. You're driving down the highway and you see a street light and it's very, very bright. And then you see in the distance there are other street lights, but they look a little blurry or they don't look as bright as the one that's in front of you. Actually, believe it or not, those are an example of a standard candle. Each of those light bulbs actually has the same amount of luminance or the same amount of brightness. It's the distance that seems to throw it off or make one look blurry versus the other. So scientists use variable stars within the galaxy or the universe, or sometimes some supernovas, as a standard candle or a standard consistence of light. So today we're going to do a really cool science experiment to understand the lightness within darkness and how that affects the distance of objects that are away from us, such as planets or the moon or certain star constellations. So this is a really awesome experiment that you can do at home using standard items that you have around your house. You're going to need a household flashlight. You're also going to need a ruler to help you measure. And you will need internet access as well as a smartphone device. We are actually going to use a light app meter. This one is called a light meter app, can simply be downloaded for free. And it's actually going to help us measure the lux or the amount of illuminance that the flashlight puts off. Now, right now I'm doing this experiment and the sunlight's coming in, and that's just so that you can actually see me a little bit better. But the darker the room, the better the results. So you'll want to do this in a very, very dark room. Also, you may see that my cat is going to jump in here in a minute because he really, really enjoys this science experiment as much as I do. And he's very fascinated with the ruler and the flashlight. So if you see him jump in, it's okay. He's just really, really excited about this science experiment as well. So the first thing that we're going to do is we're going to pull up the light meter app. You can download this for free. It doesn't cost any money. And one of the first things that we're going to do is look at the brightness of the flashlight at a very, very close distance. So I'm actually going to turn on my flashlight, and I'm actually going to put the flashlight bulb up as close as I can to the camera of the smartphone. And I'm actually going to hit the record button. And it shows that I'm getting right now 489 lux, which is the amount of illuminance that the flashlight bulb was giving me that close to the camera. Now, as any good scientist should do, you should probably mess around with this a couple of times, run a couple of trials. I try moving the flashlight around just a little bit to give me different amounts, and then maybe find the mean or the average of all three. So run a couple of trials. This time I'm getting 799 and I got 798. So maybe the more that you move the flashlight around, also I'm not in a completely dark room, so you're probably going to get different results than I do. But we'll use this as a good starting point. So we're going to have 798 lux. That is the amount of standard illuminance that you're getting from this flashlight when it's that close up to the camera. So what we're going to do now is find a good point for the cell phone. So I'm going to have the cell phone land about here, and then I'm going to use my ruler to measure about a foot away. So one ruler, 12 inches, is exactly 1 foot. And then I'm going to place my flashlight at a 1 foot distance. And I'm actually going to leave the ruler there as just a straight edge starting point. So then what I'm going to do is then record the amount of light exposure that I'm getting with 1 foot away. So I'm going to click it, and I'm only getting about 171 this time. Then again, the light is a little bit further away. I might try to tilt my phone a little bit. You might want to take 3 trials on this. 202. I'm tilting it at different angles. 200. So somewhere around the 100, 200 range at about a foot away. What I'm going to do this time is leave my cell phone in the same point, but this time I'm going to measure 2 feet away. So now I have 2 feet, and as you can see, my flashlight is getting further away. So now I'm going to measure the amount of luminance or the amount of lux at 2 feet away. 254. I'm going to try getting a few angles here. It might also be catching some of the sunlight. 229, so a little bit lower. 105, which is probably more accurate because my camera is at the top of my cell phone. So I probably want to bend it down just a little bit to line up with the flashlight. So you should notice some patterns or some trends here. You can continue to do this experiment if you want. Add on another foot, maybe do 3 feet away, 4 feet or 5 feet, and then record your results. You'll want to figure out a way to record your results, maybe in a scientific notebook. And maybe what patterns do you see? Are the numbers increasing the further the flashlight gets away, or are they decreasing? What are some relationships that you're finding between the distance away the flashlight is versus the amount of brightness that you're recording on your smartphone light meter app? So you'll want to write down some of your thoughts or some of your theories that you're finding. Astronomers actually use this relationship to calculate the distance between where we are versus where stars or different galaxies are located. So hopefully you've learned a little bit more today about the relationship between distance and light within the universe by doing this simple science experiment at home. And now you're becoming an even bigger expert in space science. So today you've accomplished step 4 of earning your space science research badge by studying the relationship between the light and distance within the universe. Definitely take the time to research more. There are a lot of really cool scientists that you can look up out there that do this on a daily basis. So take some time to research some astronomers on your own that actually study the relationship between light and the distance, and how they calculate and learn how far away certain planets are from us here on Earth, or how far away certain stars or galaxies are. The next time that we meet, we'll accomplish step 5, which is the final step of earning your senior space expert badge. And we will basically combine all of the knowledge that we've learned and do a fun project on sharing everything that we've learned, all of this knowledge. And you can go out and share it in your community or with your family members or with your friends. Thank you for joining me today on earning step 4 of your Space Expert badge, and I will see you soon.